Welcome everyone, and really appreciate your time spent to joining our webinar today. Topic is Minitab Statistical Software, Control Check. I'm Sulawati. I'm the Technical Support Specialist at Visit System. Visit System are independent local and representation for Singapore, Malaysia, and Batam, Indonesia. So today is a control check is one of the important topic, especially if you're coming from quality background. So since this webinar only 1 hour, for sure we cannot go details on this, but hopefully you're able to get something from this webinar. A few housekeeping item. Before we begin, we have a Q&A session after the presentation. Please submit any question you have and we will try, do our best to answer them all if have time. If no, we will answer afterwards by email. And then we recommend viewing this webinar on your laptop or PC for the best result. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. And then this webinar will be recorded and then upload to our website www.bizet.com and to our YouTube channel, Minitab Malaysia and Singapore. So those no problem. So it no problem if you miss anything or want to review afterwards. Okay, Minitab was developed in 1972. Probably I'm not yet here. Okay, so today Minitab is in marketing for 50 years. Minitab is a statistical software. It's a software package for the statistical analysis. So variety of statistical tools available in Minitab. Not only control chart, we have others tools, but for today we focus on the control chart. So this software, it will be powerful. Okay, statistical software, since everyone can use, whether you are statistician or non-statistician or data sciences or non-data sciences. So mean say that if let's say you have a no statistical background, but you want to do statistical analysis, so Minitab can be our one of the software on that will help you. Okay, so as we know, our flagship product is today Minitab Statistical Software. Is the complete, I think it's every complete set of the statistical analysis. And then we have also have others software inside there. We have a Minitab Connect, which is data accesses, or we look on the integration. Okay, and then we have a predictive modeling, or we call it SPM. And then we have something like online training, or we call it quality trainer. If let's say you want to know about more details about the statistical process control and so on, so maybe you can go for the quality trainer. And then we have something like project execution. So if let's say you do something DMIC project, improvement project, FME project, and so on, so maybe Minitab English and Minitab Workspace will help you. Okay, so we not focus on the manufacturing. We also have a variety of customer coming from the medical device, itself, pharmaceutical, healthcare, services like financial, aerospace, and so on. Okay, so this one is one or some tools are available in Minitab Statistical Software. Okay, so if let's say you look on the quality side, I think most of you know about the measurement system analysis, control chart for today topics. And then we have maybe next month, we go for the capability analysis, we have acceptance sampling, we have the tolerance interval. So for those, I think last 2 months, we already run the webinar for the measurement system analysis. If let's say you want to know about that, I will share the link for you in the chat box after this. Okay. And then we also have a reliability engineering. If let's say you have or you want to know about this, and then with the latest one, with the Minitab 21, we have a new tool. We call it corrective regression, including the reliability engineering part. Okay, so this one is after your process is stable, after your process is capable. Maybe you have a few planning to know about the optimization, to want to do optimization. So maybe the best way you can go for the design of experiment. Okay, so almost is it also have include not the only for the basic one. Maybe you can go for the RSM. Maybe you can go for the Taguchi. So in the Minitab, actually not only analysis part you can do, you can start for the OE, something like you can create the design itself. Okay, and then after that, you run the analysis based on that design, and then you want to do the analysis. Okay, all that thing is available in Minitab. And then, of course, now is most of us talk about the analytic. So Minitab have statistical modeling, like the regression. Okay, we have a cut, the new one is a visualization predictive modeler. And then we have a time series and get to know, starting with the Minitab 21, Minitab enhance more on the time series analytics. So if let's say you have a data, something like time-based, monthly, for example, you want to do the prediction in terms of the yield of every year or another 10 years, okay? So you can go for the time series. Okay, so this one is also available. All the tools in this framework, okay, we call it is a process validation, are available in Minitab, but not in this sequence. You need to find one by one for this case, but is not so critical to find it. It's easy to get all these stages of in the process validation. Okay. So of course, we have a lot of customer, and then coming from various sector. Okay, not the only the big company use our software, but it's SME company also use our software, as long as your objective want to do the statistical analysis. Okay, so today is we hopefully in 1 hour I will cover some overview or basic about the control chart itself, and then we go for the how to run the control chart, many ways to run to get the control chart in Minitab, and then many type of the control chart. So I will go for the variables control chart, and then we go for the attribute control chart, and then we go for the assistant. Okay, so this one is something like control chart is a tools inside the concept for the SPC, statistical process control. So let's begin our webinar with this one. Okay, many success story or case study out there, I think, show the SPC or statistical process control is one of the best tool to improve their quality. Okay, so you can Google up or go for the know about the story behind the successful of the SPC they implement. Okay, and then SPC will help you to keep process stability, your consistency, and then maybe after that you can do the predictable. Okay, so major tools in the SPC is control chart. Okay, so control chart is simple graph but very powerful tools. Okay, so looks okay. So control chart is simple since they have something like 3 line. Okay, so if let's say you have a form one graph with a 3 line, the first is we call it upper control limit, and then we have a center line, and then we have the lower control limit, and then in the x-axis actually is a time order. Okay, so it's a time order sequence, must be a time order sequence, and then this one is your measurement data. Okay, so but in the Minitab actually they provide you some color coding. Okay, so as we know, consistency is about the variation. So in the control chart, actually, you can know where variation coming. Okay, so in the variation itself, we have a two type of variation. We call is a common cause variation and the special cause variation. So in this control chart, actually you can tackle out for the special cause variation. So we go more detail of this. Okay, but in the Minitab, actually they give it you color coding. So if let's say you see on the red box here, so mean to say that this sample have a special cause variation. Okay, and then for the blue dot here means that the process is stable or in measurement. Okay, is in a good way, or just only have the common cause variation. Okay, so this one is must be no variation anywhere. Okay, but we can classify the variation to the two type. It's a common cause and then the special cause. If let's say you have a special cause, you can eliminate the variation. Okay, so maybe you can reduce the variation. Okay, I think we cannot go for the zero variation. Okay, we can eliminate and reduce the variation itself. Okay, so the sources of variation we have two is a common. Okay, it's a nature, or we call it the expected variation in the process. So what you do in your process, you must accept you have the common cause variation. Okay, and then we expect that the common cause variation in between 3 sigma here. Okay, 3 sigma, whether in above or below. Okay, 3 sigma here. So when your process in this side, okay, is expected to perform unless a change occur. So if let's say your process inside the upper control limit and the lower control limit between this, so we consider the process is okay. Okay, it's a good one. Okay, and then for the special cause variation is unexpected variation to result from unusual occurrence. So if let's say your special cause variation can be C, if let's say outside in the control limit, or they have a pattern inside in control limit itself. Okay, so basic thing, we already know if let's say outside this control limit, okay, this control limit, so we consider this one is a special cause variation. But special cause variation also can be appear in the this region. Okay, that's why we have after this how to check it about the special cause variation. Okay, and then this one is the area beyond the control limit, and then non-random pattern, where I said it just now. Okay, the variability should be investigated and the active open. So actually in the control chart, we cannot know about the why happened, but we cannot know what happened. Okay, you can know what happened on this one and say, and then you need to go for something like brainstorm why did happen on this sample. Okay, so hopefully you can define what is the common cause and the special cause. In terms technically, outside the control limit, upper or lower control limit, we consider that this one is a special cause variation. Okay, so another term with his ear is upper control limit, which is from your process. It's not the special limit. Okay, for this control chart is we have all the calculation, all the value here is coming from your process. So mean to say that if let's say you not collect your data set, so you not able to perform your control chart. Okay, so must be in your mind now. Okay, so control chart, it will be used into two different bases. The first base is to assess the stability and to find the acceptable estimate of the process parameter. Okay, the others, if let's say you go Google out why they fail or implement the SPC, is something like they fail to decide what is the process parameter in their process. Okay, so how to get the parameter in their process? you need to go, maybe you can go for the FMEA, something that one, so you can get the parameter of your process. Okay, you have your process, and then you as a SME for that process, you need to know what is your quality characteristic on your process. Okay, and then in the phase one, you control chart I use more on the exploratory tools, something like you want to build this control limit first. Okay, after you build the control limit, you can go for the second phases is you want to measure or assume that the process is stable now, and then you know about your parameter, something like you know about your mean, your standard deviation, and then the purpose of the second phase of the control chart is monitor your process. Okay, the first you want to know about the stability. Okay, once you know about your process is stable, and then you need to know you want to access on the monitoring. So we have two phases of the control chart. So it will depend on you. So after this, I will show how to differentiate, or in the Minitab, we have the features to tackle of these two phases of control chart. Okay, so this one is one of the thing you need to know before you choose the right type of the control chart. Okay, as we know, we go back to the basic one. Okay, we need to know about the type of data set itself, the type of parameter you're using. Okay, is it something like measurement, or something like measurement like length, your diameter, your weight, okay, your temperature, something like measurement is a number. Okay, so that one is, we call it variables. Okay, and then we can go for something like attribute. You have something like defect, non-defect, yes or no, is a text data. So you can go for the, we call it attribute. Okay, the same different term, but the same meaning. Okay, maybe you're using the variables. For this case, we're using the continuous or variables. For the attribute, okay, it's a text data, something like binary outcome for this case. Okay, and then the other thing, the other factor you need to consider is the how many subgroup. Okay, subgroup is something we call it the rational subgroup. So the group of units that are created under the same condition. We need to say that same, maybe same machine, same operator, but just different time. For example, every 2 hours, you take 5 samples. Okay, so every 2 hours, within the 2 hours, you must take the 5 samples to get the measurement. So his work is, we call it the subgroup. So if, let's say every 1 hour, you take only 1. So now your subgroup U is only 1 subgroup. Okay, so if let's say every 3 hours, you get 8 or 9 or 10 samples. So your subgroup now is a 10 or 9. Okay, it depends on this subgroup size to choose, okay, the type of control chart itself. Okay, because if let's say you Google out the type of control chart, we have a lot type of control chart. Okay, but the basic one, we try group them to the variables or continuous, and then group them to attribute. If let's say the second term need to consider is a subgroup size. Okay, so if let's say your n more than 1, okay, you can go for the X bar R chart. If let's say your n equal to 9, you can go for the X bar S chart. So R here is something range. S here is a standard deviation. So X bar is your average or mean, something like one. Okay, and then for the n here, only one time every 2 hours or 3 hours or whatever hours you decide, only one sample. So you can go for the individual moving range. Okay, so if let's say your data type is attribute, maybe is a defect or a defective or defect. Okay, so if let's say defective, maybe you can go for the P chart and NP chart. If let's say defect, maybe you can go for the C or U chart. Okay, it will depends the type of your data and then how you get the data set, how you collect the data set is one, two important factor before you decide this control chart. Never mind if let's say you already open your Minitab, okay, you already open your Minitab, you able to see this control, this tree diagram in this assistant. You go for the assistant, you go for the control chart. Okay. So in this control chart, actually is more comprehensive rather than we show just now. Okay, so they give it you data type. What is the data type? What is the continuous data? What is the example? How to define the continuous? So same attribute, how to define your attribute data. Okay, and then you look on this one, data collection or subgroup. Maybe you're not so clear about my explanation. Maybe you can go for this information. Okay, you can go for the online. Is the insub only a single observation. Okay, and then here is how to define the only one, only more than one, and so on. So probably you can go for the IMR chart. Okay, for this case, okay, less than 8, maybe you can go for the S bar chart. So this one is X bar S chart. It's a simple analogy. If you have a lot of data, okay, you might go for the standard deviation. So seems go for this control chart. If let's say you will take a lot of more than 8, so you can go for the standard deviation. So that's why we look on the X bar S chart rather than you look on the X bar chart. Okay, here is a range. We go after this. And then also for the attribute. So you can, what is a defective, what is a defect per unit. So they give it you something, then this one. So how to get, go to assistant, go to control chart to get that tree diagram inside the Minitab itself. Okay, so no need to Google out first and then you just open up your Minitab and then you could go for the assistant. Okay, that's with, okay. So also we have others variable, others type of control chart in Minitab. We have the T generalized, we have a UWMA. Okay, maybe this one is a go for the advanced one, but the basic here. So if you're looking on that thing, so you can go for the time weight control chart. Okay, you can go for the ray event control chart. Okay. So another thing is why we need the software to do the control chart. Because in the control chart itself, we look on the special cost variation. Okay, from the control chart, you can identify, is it common or cost variation, a special cost variation. So if let's say you want to check it is whether it's a special or the common. Okay, so you can go for this test. We call it the test for special cost variation. Actually, we have 8 type of the test special cost variation. Okay, we have 8. Okay, but after this, I will show how to get this in this Minitab. Okay, the first, this one, the first row is outside the 3 sigma. Okay, and then after outside, we look on the pattern. Okay, pattern on the sample pattern inside the process itself. Okay, so maybe 6 points in a row, all increasing or decreasing. And then we go for the 9 points in a row on the same side of center line. And then we go for the 40 points in a row, alternate up and down. Okay, so maybe you can go for this one by one. Okay, I will show after this how to get it, this one. Okay, but actually no need to access all. Okay, since you go for the first, maybe you can go for the second one. So Minitab suggests that if let's say variables chart, okay, you can go, if let's say you're not sure what type of the test must be included in your data analysis, maybe you can go for the test 1 and 2 first and 7. So for create the limit first. Okay, after you already have the limit, control limit, upper and lowest, maybe you just proceed with the test 1 and 2. Okay. So here, so I think I go for the Minitab. Okay. So here we have the case study here. Okay. So in this case study, actually every time, okay. Okay, so the quality engineer and the automotive plant monitor, okay, the length of camshaft. The engineer measure the 5 camshaft for each machine during each shift. So they have a 3 machine. So every time, every 3 machine, every time they take 5 sample. So meaning to say that now they measure your subgroup size for this case study is a 5. Every time 5. Okay, every time 5. They have a different machine. Machine 1, machine 2, machine 3. Okay, so how to get the control chart? Okay, so as we know, now is a measurement. Goes to variables. And then every time they take 5 sample. So might be in your mind, X bar R chart. How to get? Go to stat, go to control chart, go for the subgroup. And then you choose X bar R chart. Okay, so you choose X bar R chart. For this case, is comes up. Maybe I just put with the machine 1. Okay, and then the subgroup size here, maybe you can go subgroup ID or you can type it. Okay, you can type. If let's say you already know, just type 5. And then you click OK. Sorry. Okay, sorry. Okay, so I click OK. Sorry, I will go back to this camshaft. Okay, so stat, control chart, go for the subgroup, S bar chart. Okay, here I put the machine 1 for subgroups. Here is a subgroup ID. And then maybe I go for this one. Okay. See just for this case. This. Okay, click OK. And then click OK. Okay. Okay, so what we do, go to stat, go to control chart, go to subgroup, choose the R, okay, S bar R chart. So you put the machine 1, maybe I go for the machine 2, maybe it's a subgroup, maybe I go back to this one, okay, stages no, okay, click OK and then click OK. Okay, so now you get for the machine 2. Okay, so I go back to the machine 1. So based on this control chart, okay, this one is S bar chart, so it's okay. But for the mean average one sample outside from this control limit. Okay, all this value here is calculated from your data set. Okay, from this data set. No need to include the 3 sigma or some sigma or 2 sigma or 1 sigma. So this one is the X bar chart. Okay, so this one is your upper control limit. This one is a lower control limit. So I will show how Minitab calculate the that value. Okay, so for this case, okay. Okay, so for this, your range, okay, for we go for this X bar first. Okay, so every time they take it 5 sample. Okay, so they calculate 5 sample. 5 sample means that they calculate the average. So they take a sum, all this one, divide by how many sample is a 5. And then you get this value. So this value in this control chart. Another sample, sample 2, okay, they take it 5 and then they get the mean and then they put here. Okay, so up to how many subgroup? For this case, they take it for 20 subgroup. So they have a 20 mean. Okay, so if let's say you see here is a bar. Okay, bar. Okay, average of mean. So this one is we call it center line. And then this case is, we call it upper control limit. And then here is a lower control limit. So this one is how they calculate the sample for every subgroup here. Okay, so this meaning to say that this one is not the individual sample. This one is the group sample. So from the subgroup 1. This one is the subgroup 2. This one is important since most of our customers always ask how to include the spec limit. Okay, in this one. Okay, so if let's say we suggest that if let's say you want to include the spec limit in your control limit, might be best if let's say IMR check, not the for the XBAR check, because this one is the group of the sample, not the individual sample. Okay, it's more relevant. Okay, but if let's say you want to do, I will show after this how to get it or how to include the control spec limit in this control limit. Okay, so another is we call it R check. Since we go for the subgroup 1, okay, and then the range is a maximum minus minimum. So from this 5 sample, you identify which one is the highest one. Okay, divide minus with the minimum value here. So after that, you get the first sample for the R here. Go to the subgroup 2. Seems find the minus 1, maximum minus minimum. So you get another dot here, another sample here. So up to 20. So this line, center line, is the average of your range. Okay. Okay, so that's why here you look on this one, only one dash. Okay, up this one. Only we call it the R average. Okay, R average. But for X bar bar, you have a 2 here, 2 line here. It's a X bar bar. Means that it's average for every sample. This one is the only average sample. And then they provide you UCL, and then here is LCL. So all these things is from the Minitab. You don't need to find out one by one for this case. Okay, clear how to get the sample in this one. Okay, I go back to the Minitab. Okay, so we try this one is the mission 2. Okay, so okay, another thing is the best is they give it you something. This one is a test 1. Okay, it's a 1 point more than 3 standard deviation from the center line. It's a fail. The test sample fail is a sample 8. So you go back to this one, it's the sample 8. So if let's say you can hover your key, okay, here, and then you can see what this means. Is sample mean, and then they give sample. What sample is a fail from this control limit. So we can decide that this mission is not unstable. It's not out of control. Okay, so from here, maybe you can further with your brainstorm, or you can further with the 6M method, machine, and so on. Okay, environment. So you can drill down on this one. So that's why in control check, you cannot know about the why happened, but you can get the what happened to your process itself. Okay, you get it? Hopefully you get for this one. So I go to stat, go to control chart, you can go for the subgroup X bar chart. Okay, so just now we see on this one, we have 8 points. So how to get the 8 test special? Okay, so go to Minitab. Okay, so where you can go to the X bar option. Okay, you go for the test. I will do open the X bar. Okay, control chart, S bar, subgroup, S bar R. Okay, you go for the S bar option. So if let's say you choose the S bar S, you go for the S bar option. So in the S bar option, you can go for the test. Okay, so by default, Minitab just look on the one. The first test is what is the first test? Is 1 point outside from the K standard deviation. So K here is a 3 sigma. So let's say you have a 2 sigma or something that one more precise on that. So you can customize it on this. Okay, so if let's say you want to perform all the tasks special, so you just point, or maybe you have a preference only test 1 and 2. Okay, maybe you can go for the test 7. That's one. Then you click OK, and then you click OK. So Minitab will run it to you to test every 8 tests. Okay, or every how many tests they provide to you. Okay, what you choose it. So I go back to this one, go to the X bar option, and then you choose the test here. Okay, basically if let's say first time you want to do control chart, establish your control limit. Maybe you can check by the test 1 and 2 and the 7. After you know your process now is stable, so the purpose of your control chart to monitoring, so you can go for the test 1 and 2 only. Okay. This one is depends on your company. Okay. Depends on company. This company that the way they're using, maybe just only one test, or is it okay and then okay. So it all depends, not the compulsory, but by suggestion that if let's say the variables look on the first time, go for the test 1 and 2 and the 3. Maybe if let's say you look on the all, maybe you have something like not so good. Okay, so maybe you need study on this one based on your preference. But in Minitab, how to get, so you can go further start control chart, subgroup S bar chart, or X bar option. So you can get the test here. Okay. Another thing might be we want to know now. Okay. For example, I go back to the S bar chart, subgroup S bar chart. Okay. I go for the machine 1 only. Okay. Machine 2, and then click OK. Okay. So based on this machine 2. Okay, now is a good. Okay, so the purpose I want to do the control chart to monitor. So now I get the historical data, historical parameter. I get the mean. Okay, I get the standard deviation. So you collect the new data set. Okay, you collect the new data set. So, but you want to have the control limit with the same control limit. Okay, so you go to start control chart subgroup size, you go for the S bar chart, you go for the S bar option. Okay, so here is the parameter. So you, let's say you have your own mean. Okay, you have your own mean. For example, here maybe you go for 600. Okay, your historical data. Maybe 7. Okay, and then here is 1 point something. Okay, I just put any numbers. Click OK, and then click OK. Okay, so now you get the new you imagine now you collect the new data set, but using the same control limit here. Okay, so the first time you do, you want to this line. After you get this line, you do some improvement or something that one, maybe you can go for the second part. It's a monitoring purpose. This one is the stability. This one is for monitoring purpose. So how to get, go back to this one, all the features to do in the S bar option. So here is a parameter. Okay, so you can go for the parameter, historical data or parameter here. So I think if let's say your company already do that process for 5 years, maybe you already have your historical parameter. Okay, and then maybe you can use this parameter. So in this line control limit, actually they already put in here. Okay. Okay, so how to get this one? Already done it. Okay, make it pattern. Okay, okay. So this one is something like just show you how to tackle. Okay, how to tackle this one. So you can omit the process. So this, for example, here is sample A is outside the control limit. So maybe in term reality, you go for the brainstorm, you do something improvement, and then you get the way how to tackle this, and then you can omit this sample. because you want to estimate the new control limit. If let's say you do improvement, okay, so you can able to do. Okay, I will go back to the Minitab. Okay, how to get it? Go to stat, control chart, subgroup, S bar. I go back to the machine one. Okay, and then I go further S bar chart. That one I don't want. Okay, estimate. Okay, so omit the subgroup. So now we know subgroup 8. So you just put the subgroup 8. You click OK, and then you click OK. Okay, subgroup 8 here. So this one is a subgroup omitted from the calculation. So if let's say you see this way, this limit, okay, this limit, control limit is a differently. Okay, because they omitted this sample, okay, on this calculation. Okay, so beware here is a have a subgroup omitted from this calculation. So that's why its control limit is different here. Okay, so instead 20, be other 90. But in the visualize, it also appeared that, okay, the sample, but just different control limit itself. Okay, so no worries, Minitab will give you some trigger up here. It's a subgroup omitted from the calculation. Okay, go back to this one. Already done it for this case, and then okay, we go for the attribute. Okay, so this one is one of this case study. The quality engineer assess whether the process used to manufacture light bulbs is in control. Okay, the engineer tests 500 light bulbs each hour for the 3-8 shift, and they record the number of bulbs did not light. We consider that is a defective. So I will go to the Minitab. Okay, go back to the Minitab. Just the second one, defective. Okay, so every time they collect the 500, okay, every sample here 500, and then they see the 5 defective. Okay, so second, A, and so on. So this one is, we consider this one is attribute. Okay, so go to stat, control chart. Okay, go for the attribute. So for this case, we choose the NP chart. Okay, since every time 500. Okay, so this one is a defective. Your subgroup size is 5. You can type, or maybe you can insert the subgroup ID here, and then you click OK. The same, click OK. So now you get the NP chart. So based on this NP chart, one of point here, okay, so point what sample is the sample 16. Okay, so outside from the this control limit. Okay, whether it's outside for the upper or lower, we consider that the process is out of control. It's out of control. So all these things, maybe you want to check others testing, go to the test, and then you choose perform all the one. Click OK, and then click OK. Maybe you look on the pattern itself, but we have another testing here is a fail here. Okay, so what is the fail? 6 points in a row, or increase or all decreasing. The what sample? Sample 9. So they give you information. Okay, for this case. Okay, so this one is the attribute. This one is the expert chart. This one all using the stat menu. Okay, but in Minitab also we can have another way. We go for the assistant. Just now I show, go for the assistant control chart. Okay, so for this case, we go for the data collection, subgroup size 5 only. Okay, so you go for S bar chart. So in one group, okay, so only mention 1. Okay, constant is a 5. Okay, so this one is considered is the first time estimate from the data. Okay, if let's say you want have
historical, so you can go for the known variables. So mean that you want to access on the monitor, you monitor the process. So for this case, I just want to estimate from the data set, and then you click OK. Okay, so now you get the result from the assistant. In assistant, actually they provide you some summary report, okay, stability report, and then you give it you the report card. Okay, so this one is the from the step menu. Okay, from the step menu, you get the control chart and then your testing. But in the assistant menu, you can get the summary report. Okay, so they give it the comment here, and then they give it you something this one. Okay, and then I think this one is a good one. Is they give you the stability report. They give it you something, load this pattern. Okay, if let's say you do the manually, you need to calculate. Okay, this one what this by the 6 point. So you need to calculate one by one to testing for the second test special cost variation. So that's why you need to have the software will help you to identify this pattern or special cost of variation. And then they give it you the report card. Okay, and there's something amount of data is a good since 100. Okay, more than 70% more data set, and then it's a correlated data set and so on. So they give you some assumption before you get further. So this one is a two-way, whether you're using the step in the step menu, step control chart, what control chart you want to, and then you can go for the assistant, you can go for the control chart. So we have a two-way, whether step menu or control chart. So personally, if let's say you are the first time, maybe you can go for the control chart to get the knowledge, okay, before you get further with the step menu. Since the step menu have something like, just now I will show it, okay, if let's say you have a option, so you want to proceed the control limit with the same control limit since you already have the historical data set, okay, but you try to do the predictable. Okay, if let's say you you know what sample, and then you know what happened, and then you try omit from your sample what happened to your pattern, and then maybe you can go for the test, not only one test, maybe you can go for other tests, and then maybe you want to display that one, and then you can storage. Okay, you can say this one. So personally, if let's say you first try, maybe go for the using the assistant, maybe you expert one, go for the step menu. Okay. So in summary, stable and in-control process is prerequisite for further analysis such as capability or predictive analytics. Okay, so if your process is stable, you can predict the future, your performance, and improve it. It's a capability. So however, okay, this thing is important. A stable process does not necessarily means it's a capable. Since capable, we have another tools, we call it capability analysis. For this case, only look on the stability or look on the in control or off control. But this stability process is important to evaluate the capability. Okay, one of the assumption to do capability or CPCPK must look on the stability first. After you rely on the capability. So if let's say you have a good measurement, just now I showed that last 2 months we conduct the measurement system analysis. So you can go for the measurement itself first, and then we go for the control chart. After this, you try measure about the capability. Okay.